Back with day 35 here. I wanted to give a problem like we saw today on some of our work, but in no calculator form. So go ahead and copy this question into your notes. You can pause it if you need to. And let's talk about it. So here's the problem. It says an object's, it should be a apostrophe there. An object's position for t greater than 0 is given by x of t equals t squared minus 9t plus 7. At what time or times does the object have a speed of 3? Okay, so one of the things I want to talk about in this video is we need to be able to look at problems and immediately know what to do. So the question here is asking for time values where the object has a speed of 3. That word speed, again, is very important. Anytime you see the word speed, you should understand that you might be trying to get tricked here. Okay, so for an object to have a speed of 3, what does that relate to? Position, velocity, or acceleration? Well, that relates to velocity, right? I want to know when we have a velocity, right, of 3 or negative 3. So we need to understand that speed is the absolute value of velocity. So there are two different velocities that could give us a speed of 3, positive 3 and negative 3. Another problem here is I don't have the velocity equation. I only have the position equation. Well, that's no real problem, even without a calculator. The first thing I want to do here is I want to get an expression for v of t. Well, v of t is simply the derivative of x of t. So the first thing I want to do here is I want to get an expression for v of t. So v of t would be the derivative of x of t. So that would be simply 2t minus 9. Okay, and I want to know when this velocity equals 3 and when this velocity equals negative 3. I'm not plugging in 3 for t. That would be what's the velocity at time 3. That's not the question. The question is when does my velocity equal 3 or negative 3? So what I want to do here is I want to write two equations. I'm going to set 2t minus 9 equal to 3. And I want to set 2t minus 9 equal to negative 3. If I had my calculator here, I would graph my velocity, graph the horizontal line 3 and the horizontal line negative 3, and I'd find those intersections. But I don't have a calculator here, so I want to set my velocity equation equal to 3 and equal to negative 3. Since it's no calculator, the numbers are a little easier to work with here. Solving the left equation, I add 9, I get 2t equals 12, and I get t equals 6 as one of my answers. Solving this equation, I add 9, I get 2t equals 6, and I get t equals 3 as my other. So those are the two times at t equals 3 and t equals 6. My object has a speed of 3. That make sense? Okay, so let's talk about looking at problems and knowing what to do. Okay. So let's say we're given x of t, and we want v of 4. What do we need to do in this scenario? Well, we need to go from a position equation to a velocity equation. So we need to do the derivative. So we need to derive x of t to get v of t. Then plug in 4 for t. Okay. I'm just going to go through a lot of these scenarios. Okay. Given v of t. So we're given v of t, and we want a of 2. What would we do here? Well, again, if I was given v of t and I wanted a of 2, I'm going to need to do a derivative, right? So I'm going to have to derive v of t to get a of t, then plug in 2 for t. It says 4t, not fort. Okay. So to go from v to a, I need to do a derivative. To get a of 2, I plug in 2 for t. How about this? Let's say you're given y of t, and you want a of 6. Now, y of t is another form of position equation, right? So I'm given a position equation, and I want to get to the acceleration. What would we do? Well, we'd have to do the derivative of y of t twice. So I'd want to do 2 derivatives of y of t to get a of t, and plug in 6 for t. Okay. Next scenario. What if I'm given x of t, another position equation, and I want object at rest. So I'm given x of t, and I want to know when is the object at rest. Well, I know an object is at rest when its velocity is 0. So first I need to get to velocity equation. So I'm going to derive x of t to get v of t. Now I want to know when v of t is 0, right? I'm not plugging in 0 for t. Now I'm going to set v of t equal to 0, and I'm going to solve for t. Okay. So an object at rest, I know I need to get v of t equal to 0 and solve for t. In this particular scenario, I would have to do the derivative of x of t to get v of t. Okay. Next scenario. You're given v of t. I want to know, so that's what you're given. What we want is to know if speed is increasing or decreasing at t equals 5. So again, pause the video, think. What do I need to do? Right? I don't need to solve this one. I just need to figure out what to do. And the actual problems will solve them. So what do we need to do? Well, first we need, anytime speed is increasing or decreasing, I need to check the sign of v of t and the sign of a of t. I need to check both. So first thing I want to do is plug in v of 5. Right? So first find v of 5. If I have a calculator, I'll graph v of t and trace 5. If I have an equation, I'll plug 5 in for t and solve. I just need to find v of 5, and then I need to know, is it greater than or less than 0? Okay. The next thing I need to do is I need to find a of 5. I can do that by doing a hand derivative of the velocity equation. I could do that by doing the derivative through my calculator. Either way, I need to find a of 5 and determine, is it greater than or less than 0? And lastly, I need to check signs. if v of 5 and a of 5 are same sign, speed is increasing. If v of 5 and a of 5 are different signs, then speed is decreasing. Okay? Next. Let's say we're given x of t. And I want object going right. I want to know, where is the object going right? Well, I need to know an object goes right when its velocity is positive. So the first thing I want to do is I want to get to my velocity equation. So again, I'm going to derive x of t to get v of t. Now again, to know where v of t is going right, I need to know where v of t is positive. To know where v of t is positive, I must figure out where is v of t equal to 0. Solve for t. Then I want to plot on v of t number line and do sign test. After I do my sign test, I want to report all the interval where v of t is plus. Okay. If I was given x of t and I wanted to know where the object is going left, I would do everything the exact same, except at the end I'd report where v of t is negative, right? Where v of t is less than 0. Okay. What about if I was given v of t and I want to know where it's going right? Well, I don't have to do a derivative then, but I still need to figure out where v of t equals 0 and solve for t. Okay. Next scenario, this will be our last scenario. We're given a v of t equation. I want where object changes direction. So again, what I have to know from the notes earlier, an object changes directions when v of t switches signs. The nice thing here is I was given v of t. All I want to do is figure out where v of t changes signs. Well, the first thing I need to do, an object is going to have to change signs going through 0. So, set v of t equal to 0 and solve for t. If I was given x of t, I'd have to do a derivative to get v of t, then set v of t equal to 0, solve for t. Those are our candidates. So plot candidates on v of t number line. So I'm going to plot, maybe I got 2, 5, and 8. I'm going to plot those on a v of t number line. Now I need to do a sign test. Okay, I need to do a sign test around those candidates, and I'm only going to report answers if the sign actually switched at that number. That's it for today. If you have any questions on the homework, let me know. I can do those problems in my video tomorrow. Talk to you later, guys. Bye.